A hypothesis testing example where we're going to be finding a p-value to determine if we reject or fail to reject the hypothesis test here. So this is one of your homework problems. All right, let's go and read through it. A consumer group claims that the mean minimum time it takes for a sedan to travel a quarter mile is greater than 14.6 seconds. So greater than 14.6 seconds is already mentioning one of the hypotheses. All right, we conduct a sample. So a random sample of 20 sedans has a mean minimum time of 15.5 seconds and a standard deviation of 2.11 seconds. So the mean is a little higher than the 14.6, so it might be that the average time is going to be greater than 14.6, but we'll have to see with this size standard deviation and this sample. This standard deviation mentioned sounds like it's the standard deviation for these 20 sedans, which would make that the sample standard deviation. So we're going to use a t-distribution. Our cutoff level here is 5%, our level of significance, so alpha is 0.05. And are we going to be able to support the claim? Okay, so let's go ahead and first determine some of our information given. The population mean mentioned to compare is 14.6 seconds. We'll still need to finish that to determine the official hypotheses. The sample mean, x bar, is given at 15.5 seconds. The sample standard deviation is given at 2.11 seconds. Alpha, let's first do the sample size, is 20 sedans. Alpha is given as 5%, or 0.05. All right, we'll need some of these in our calculations. So to start, let's figure out the null and alternative hypotheses. So the mean that we're mentioning here is the 14.6. The first one is mentioned, the mean is greater than 14.6. So if we do not have an equality, that is the alternative hypothesis. The mean is greater than 14.6. The null hypothesis is then the opposite to that. So each of these hypotheses are always complements to each other. The null hypothesis should include the equality, and the alternative hypothesis should not include the equality. So then now we just need to make the opposite of that. The opposite of being greater than 14.6 is being less than or equal to 14.6. All right, so step one, we determined our hypotheses, but we still have to determine which is the claim. So the claim is whichever one is mentioned as the claim. Often you'll see the word claim. The consumer group is claiming it's greater, which would be the alternative. This will mean if we can support or reject. Were they correct or were they wrong? Did they bet correctly? All right, now we will calculate the test statistic. So we had said before that since we have sample standard deviation, we are going to use a t-distribution or a t-score for this problem. So to calculate the t-value, we're going to take the sample mean and subtract the population mean. So the sample mean is 15.5. The population mean being compared to here is 14.6. And then divide. We need to divide by the sample standard deviation divided by the square root of the sample size. We need to divide by all of that. The sample standard deviation is 2.11. And the sample size is 20. So this will calculate our test statistic. So our test statistic is 1.9. This is right on that border of commonly around 2, so this may or may not end up rejecting. All right, so let's go ahead and check our hypotheses and the claim, and we'll check our test statistic also. We are mentioning about means. Our null hypothesis, less than or equal to the 14.6 mentioned. Compare that to greater than is its complement. And the one being claimed by this consumer group is the alternative, that it is greater. Right, we found the test statistic, the t-score for this problem. We want to round it to 2 decimal places, so it'll be 1.91. All right, and then let's find the p-value. So this is a right-tailed test since the alternative is greater. And so to find the p-value, we're going to use a dot dist and a t dot dist since this is the t-distribution. And we can use the right tail function so we don't have to do the complement on our own. The x value we're looking at is the 1.9. The degrees of freedom is the sample size minus 1. So the sample size was 20, minus 1 is 19. Right, our p-value looks pretty small, about 3.5%. We're going to want to round that to 4 decimal places, so 0.036 when we round. All right, our decision. So are we going to reject or fail to reject? Alpha for this problem is 5%, 0.05, and our p-value is less than that. So this is a somewhat unlikely scenario to happen, assuming that the population mean is actually true. If the population mean were really 14.6, it's only 3.5% that we get a sample mean of 15.5 or more, which is somewhat unlikely. So since our p-value is small, smaller than our alpha, we are going to reject. So let's highlight that. Our p-value now is less than alpha, so we are going to reject the null hypothesis. So reject the null hypothesis. This only has the option for greater than. It is not greater than, it is less than, so we'll choose is not greater than. Right, lastly, so what did this all mean? How do we interpret this in more real-life terms? So initially, for any hypothesis test, you assume the null hypothesis. We assume that the mean was less than or equal to 14.6 seconds. Then our sample is going to tell us that that's unlikely. So if we are rejecting the null hypothesis, we are essentially saying that this is wrong. And we can imagine crossing that out. So if we imagine crossing this out, let's make the alternative red to indicate that. So the null hypothesis is now we're thinking incorrect, and our guess is that the alternative hypothesis is the right one. This consumer group is claiming the alternative. They are claiming what we are thinking is the right hypothesis. So we agree, and if we agree, we can then support their idea. So our wording is going to be support. If the claim is on the alternative, you will always word it as support. If the claim was on the null, you would always word that as reject. So we are agreeing with them, so there is going to be enough evidence to support them. that level of significance is 5% for this problem. I think this is going to want that as a whole number since it says percent. And this is just restating the claim. So what was the claim? It was the alternative hypothesis. So that claim was that it was greater than 14.6 seconds. All right, looks good.